Okay, question 8. I'm going to draw this out again, and a block acting like that. And I don't like pushing, as I said before, so that is going to be pulling it at 20 newtons. Okay, we've got 20 newtons, mass of 1.5, so 1.5 lies there, therefore its weight component acts vertically downwards at 1.5 g. The angle here is 30 degrees, so 30, 30 degrees. Okay, we're going to need the normal reaction, I dare say, which is just there. The line of action of the force is the same as the vertical. Right, it's on a rough plane. Okay, so we've got that. It says find the magnitude and direction of the frictional force. Now, it could be acting upwards, as in that's it really small amount, it's ready to go fall down, so it could be acting upwards or downwards. The only way you're going to compare which way it is by first of all componentalizing this force, and you're going to see which way the frictional force is going to have to aid one way or the other to keep it in equilibrium. Okay, and it is so which is an equilibrium, so it is there. That's the important thing there. You got the bit going this way, so we know that if it's 30 degrees there, you know it is 30 degrees just there. Okay, so the bit going upwards is the force 20, and it is cos 30, and the bit going down here is the force 20, and it is sin 30. Now I'm going to do exactly the same, componentalize the weight. You've got a bit going down here and a bit going down here, and again, as I've always told you, that this is 30 degrees just here. So this is the force 1.5 g, and its component is going to be cos 30, and the bit going down here is the force 1.5 g, and its component is sin 30. Now I don't know whether F max is acting there or there, but we're going to see now by looking at these two just here. So the result, so therefore for part A, we're going to resolve without any friction. Resolve, no, I suppose it's resolve. We're just going to go straight into doing it and just saying up is positive. Okay, we've got 20, it is cos 30, and it's take away the only other force if we don't include friction is 1.5 g sin 30. We're just going to look at what this is telling us. Okay, and we've said up is positive. So if up is positive and this gives us a positive answer, it means there's an excess force going upwards, it means friction's going to be acting downwards. If this is negative, it means there's an excess force going downwards and friction needs to be upwards to be assisting and keeping it in equilibrium. So looking at this, we're going to look at that result across here. We've got 20, and it is cos 30, close brackets, minus, open brackets, 1.5 times 9.8 times sin 30, sin 30, close brackets, equals, and we get a positive 9.97, 9.97. Therefore, there's an excess force going upwards, so I can say that's going upwards. Therefore, find the magnitude and direction of the force acting on the block. Okay, the magnitude and direction of the force acting on the block is it must be acting. Find the magnitude and direction of the frictional force acting on the block must be acting downwards. Okay, to stop that, because if that was smooth, then it'd be accelerating up there. So we need this to oppose it. Okay, so find the therefore friction is 9.97 newtons. It has to be that, and it is acts down the slope. So we've got all of that just by looking at this issue just here between the force, pulling force, and the weight dragging it down. What's the result? If an equilibrium, then which side does the friction need to be at? He then says, so we're not necessarily at friction, this isn't friction max necessarily, because it just says it's in equilibrium. It's not necessarily in limiting equilibrium, so just that's all we know, it's just friction, okay? That's important to come to. We've got part B, then goes on to say, find the normal reaction between the block and the plane. So for that, we are going to resolve vertically, perpendicular to the plane, and we're going to use net forces is equal to 0. The sum of the forces is equal to 0. So R is the only one acting upwards, so I end up with R minus the two acting downwards is the weight component, 1.5 G cos 30, and also the component of the pulling force acting downwards as well, so that's minus 20, and it is sin 30, and that is equal to 0. So quite clearly there's nothing unknown here. We've got R is simply equal to, and throw that over, you got 20 sin 30 plus 1.5 G cos 30. So R quite clearly is, what happened then? R equals that. That's it. Okay, R is equal to, type that into the calculator. We end up with 20 sin 30, well that's 10. We end up with plus brackets 1.5 times 9.8 times by cos 30. Cos 30, close brackets equals. So we got R to be 22.7, 22.7 newtons to 3SF. Okay, so it says find the normal reaction between the block and the plane. What can you deduce about the coefficient of friction? Between the block and the plane. Well, we know that the friction, so this is the important bit, you might not have seen this question before, you're not at F max. We know that the friction, F, okay, friction must be less than or equal to F max, yeah? The friction that we're using just here must be less than or equal to F max. So we know that the friction is 9.97, must be less than or equal to mu R, and again that is 22.7. okay, so, and again I would use these unrounded answers. I stupidly didn't store this on my calculator, but I would use these as unrounded because you're going to incur an error here. You can see therefore by deduction mu must be greater than or equal to the result of 9.97 divided by 22.7, and we know that this must be in the range between 0 and 1, otherwise it wouldn't make sense. Okay, so let's just work that out, and again I would not use my unrounded answers. I've only got one that is unrounded. Let's see how easy that would be to go back and get that. It's easy enough. I can't bring myself to use things there, so I'm going to call that B. Shift stow B, okay, AC. So that is stored as B down there, just remind myself. And this one here right at the beginning is simply 20 cos 30, that's 10. Sorry, that's not 10, that's root 3 over 2, so 10 root 3. I can't, so 20 cos 30, close brackets. I've got minus, open brackets, and I've got 1.5 times 9.8 times by sin 30. Sin 30, close brackets equals, and there it is. So shift stow A, AC, and all I've got to do down here, okay, that is A, and that is simply do my previous answer divided by my alpha B, and that gives us that to 3 sig fig is 439. So I know that mu must be greater than or equal to 0.439 9.439, and that's all I can deduce. That's it, that's right, and that's it. So it says, what can you deduce about the coefficient of friction between the block and the plane? I can deduce that the coefficient of friction must be greater than or equal to that. Okay, I hope that makes sense. What you have to understand is that this 9.97 is just the friction needed. It's not necessarily at friction max, but I know that that must be less than or equal to F max. It can never exceed that. It can only ever equal that. So 9.97 is less than or equal to F max is mu r, and we've worked out r, and there if you can divide by that, and that's the answer. Okay, I hope that helps.